Abilene, Texas. $500 billion on raw Texas dirt.
Rack 1, lowering. Clear on all sides.
40 miles of fiber. 5 gigawatts of power capacity. Built from absolute zero.
12,000 cubic yards poured in a single weekend. Tolerance, 0.001. When live next year, this single facility trains models 100 times the scale. Thermal check green across all nodes.
5 gigawatts. That's 30 times what a city this size normally draws.
40 miles of fiber in a single trench. No single point of failure allowed.
Fiber lay section 4, passing verification.
12,000 cubic yards. Poured in 72 hours. Tolerance, ½ an inch across the entire floor. 300 million pounds of structural steel. Every connection verified twice.
Final beam locked, section 6 verified.
40,000 tons of cooling infrastructure. 12 months to full capacity. 500 petabytes per second of internal bandwidth. No data center on Earth runs faster. 5 gigawatts demands something most cities never build. Stargate gets 2 independent power stations.
Primary breaker seated. Isolation confirmed.
First batch, 144 processors, collectively equivalent to 8 monadult person million CPU cores. Dwarfs everything deployed before this.
40 miles of fiber in the first trench alone.
Rack 1, lowering fine. Stand by.
12,000 cubic yards poured in a single weekend.
Pour station 3, pressure holding.
5 gigawatts. That's more power than Dallas consumes.
Power feed 1, impedance nominal.
Each connection verified to micron tolerances before power on. 40,000 server racks.
2,500 per week.
Rack 1, seating the interconnect board.
5 gigawatts continuous. The equivalent of powering Dallas.
40 miles of fiber laid in 90 days.
Conduit section 7 complete. Fiber tension nominal.
Concrete sets in 72 hours. After that, you can't move a newspaper hang.
Section F7 approaching target elevation, holding
48 hours per rack. Inside this hall, 6,000 servers will train models bigger than anything that exists today. 40 miles of fiber, single trench, tolerance 0.3 millimeters. When live, latency inside this building is measured in nanoseconds.
5 gigawatts arrives here in exactly 12 minutes. That's enough power for 3 million homes, all of it dedicated to compute.
78 degrees Celsius. That's the thermal floor. 1,000 simultaneous test operations running across 12,000 cores, all synchronized. 42,000 chips. Arrayed across 5 city blocks of cooling infrastructure.
5 gigawatts. Same power draw as 3 nuclear plants. Built into 1 Texas basement. 28,000 miles of fiber laid before first server powers on. 12 million gallons per hour. Coolant temperature held within 0.3 degrees Celsius.
42 server bays in this building alone. Each one draws more power than a small city.
Rack 1, lowering chase. Clear on the left.
Electrical infrastructure of this scale. Nothing else in North America has attempted it since 1995.
40 miles of fiber. Latency target, 1.3 milliseconds coast to coast.
Splice count at 9,400.
Cooling system alone required custom engineering grow. 5 million liters per minute circulation rate.
Pressure holding at 4.2 bar, nominal.
First GPU rack settles into floor. 3,000 more to follow.
Rack 1, lowering secured. Moving to next bay.
5 gigawatts means powering a city of 3 million people from one building.
Turbine 2, pressure nominal. Proceeding to next manifold coupling. 40 miles of fiber in 72 hours. 4 nodal person, 100 tons of cable.
Spool tension holding steady, advancing junction point to marker 53.
Concrete sets in 72 hours. Precision to 3 millimeters across the entire foundation. 40 miles of fiber. 2,000 concrete pilings. None of it works without what goes inside. 5 gigawatts, equivalent to a nuclear plant. running full capacity before 2026.
Transformer 1, locked in position.
Each GPU rack dissipates 30 kilowatts. Multiply that by 50,000 units.
1.2 million kilowatt hours per day.
Running continuously.
The facility pays for itself in compute. 5 gigawatts, enough to power a city the size of Austin.
Rack 1, lowering to position. Check alignment.
Each turbine delivers 1.7 gigawatts. Multiply that by 5.
Phase lock check. All 3 lines nominal.
40 miles of fiber to the substation moorings. 0 latency tolerance. 12,000 cubic yards poured in 72 hours. This foundation doesn't settle.
Section 7 depth check. On spec.
40 miles of fiber. Single weekend pour, 12,000 cubic yards.
Rack 1, lowering. Steady on the load. Mark.
Thermal load at full compute, 2.3 megawatts per row. 3,000 rows. Do the math. Coupling confirmed, pressure nominal, next blade ready. 5 gigawatts continuous draw, equivalent to 2 million homes, built into one building.
Final board seated, LEDs green across the board, power sync nominal.
Rack 1, settling on mounts.
First GPU rack settles into position, one of 10,000 before completion.
4,200 megawatts delivered from combustion turbines, feeding $500 billion in computation.
Manifold sealed, pressure holding.
12,000 fiber strands, each carrying terabits per second. That's the nervous system of the entire facility.
Every frame tolerance, 0.05 millimeters Kernstrom, tighter than manufacturing specifications for surgical instruments.
5 gigawatts of continuous power. That's what's running through these cables right now.
40 miles of fiber optic already laid, 10,000 more to go before year end.
Insulator stack 7, resistance nominal, clear to seal.
At 19.99% uptime, 1 second of downtime costs $40 million. 72 hours. If the pour stops, this entire foundation cracks. No restart. 42,000 GPUs across 4 server halls. First one lowers into position.
Rack 1, lowering clean.
5 gigawatts on demand. Each turbine, third adult person 100 tons. Precision to 1/10 a degree.
Coupling locked, pressure nominal. 40 miles of dark fiber, direct line to 3 backbone exchanges, redundant routing to 6 separate substations.
Conduit 1 secured, depth verified at 8 feet.
12,000 cubic yards poured in 72 hours. Floor plate tolerance, 4 millimeters across the entire 200,000 square foot base. 48,000 components per rack. Each one tested to 105 degrees before ship.
7, lowering on mark, over.
90 seconds per installation, 12 hours per bay. The entire facility, 800 bays.
5 gigawatts. Delivered across 3 redundant substations 12 miles apart. Not one point of failure.
Relations. When this facility reaches full capacity in 26 months, it trains models 300 billion parameters.
2,000 racks arrive each week.
Rack 1, lowering clean. Cooling tolerance, 0.05 degrees Celsius.
Tech Bay 2, torque spec confirmed.
4,800 volts per rack. Redundant supply lines. Pre-staging verification, 30 minutes per unit. 42,000 GPU chips, every one tested at 5,000 volts before it leaves this line. Inter-GPU latency, 0.4 microseconds. The delay between 2 thoughts, measured in light itself.
Ain't adult person months until this facility becomes the fastest supercomputer ever built. 3 months into construction.
500 equals 3 years equals $3,000 per square meter of this floor. Or the intolerant. The bottleneck isn't the hardware. It's the thermal subsystem, cooling 40,000 watts per rack.
40 miles of fiber. 40 nanoseconds of latency end to end. Everything fails if you miss the tolerance. Each pod pulls what a small city consume. 5 gigawatts total when live, every single unit accounted for. By next spring, this trains language models that operate at scales leading AI lab couldn't run last year on 50 separate campuses. 50,000 workers. 25 megawatts per floor. Just getting the first rack bolted down.
40 miles of fiber. 40 miles of cooling loops. Everything synchronized to the microsecond.
12,000 cubic yards poured. Tolerance, 0.5 millimeter across the entire foundation.
Grid Section 7, tolerance verified, marking for sign-off.
5 gigawatts routed through 2-inch copper. That's enough for 300,000 homes.
48,000 tons of steel arrived this month alone.
Rack 1, lowering, mark.
5 gigawatts of power. Routed through systems that fail, they redesign. Systems fail again.
40 miles of fiber. 7th 2 hours to lay it all.
Alignment confirmed. Laser locked.
When this comes live in January 2026, training windows compress from weeks to hours.
Final termination locked. Standby for power-up sequence.
First GPU rack down. 49,909 to go.
Rack secure, marking next position.
40 miles of fiber. Single point of failure. There isn't one.
Fiber bundle holding at position 27.
12,000 cubic yards poured in 72 hours. Cracking. Not allowed.
Temperature holding at 18 degrees, continuing Section 3. Alignment 2 microns, that's 0.02 millimeters per mounting point.
Rack 7 locked at tolerance, moving to position 8.
5 gigawatts of power. First next-gen AI chip unit locks into foundation. 12,000 cubic yards poured in 72 hours. Tolerance 4 millimeters.
Pour Sector 3 active, grade nominal.
40 miles of fiber laid underground. Each connection point tested 3 times before sealing.
First GPU rack secured, 3,000 more to go.
Rack 1, lowering clear.
24/7 operation. 365 5 days a year.
5 gigawatts of power demand. That's equivalent to 300,000 homes.
Thermal tolerance 0.5 degrees Celsius. Installation precision 2 millimeters across 200 meters.
Thermal spec within range, pass.
Rack 1, lowering clear. 50,000 workers. 500 billion on the line. When this comes online in 26 months,
Stargate goes live in 2026. Follow the final phase tab. Next infrastructure milestone ships in 6 weeks.